Chapter 9, Section 2 is quadratic functions. So what we're going to do in this section is show you a different way other than a table for graphing a quadratic function. Quadratic equation, you can think of it the same way. And so far all you know how to do is make a little t-chart and plug in your x's and your y's. And we're going to show you a way of doing that without, and also point out some things about this. Besides just graphing it, we also want to point out some characteristics about this equation. So first up is understand that a quadratic function is in this form. Now, b and c could possibly be 0, which means they wouldn't show up, the bx part and the c part, but a has to be something has to be something greater than 0. Okay, or sorry, a cannot be 0. It could be a negative number, it could be a positive number, but it cannot be 0. Okay, so here are a couple of different graphs. Okay, and as you see from section 1, is all we had in section 1 was the a part and the c part, right? B was always 0, and it was always the y-axis was the line of symmetry. Well, now you're seeing the line of symmetry being shifted, and you're seeing this line of symmetry being shifted, and so we're going to show you kind of how that happens. So we'll start off with this. If you have the equation ax squared plus bx plus c, the things you want to pay attention to is c is the y-intercept. Okay? The next thing we can find out about this equation is the line of symmetry. And that is located where x is equal to negative b divided by 2a. And then thirdly, the x coordinate of the vertex, so the x coordinate is this again, negative b divided by 2a. And with that x coordinate, you can find the y coordinate, and if you have an x and y coordinate, you therefore have the point, which is the vertex. So let's look at one of these. So here's the equation, and we want to graph this function. Now, yes, we could start a table and do it that way, but I'm going to show you this. So the first thing is your y-intercept. Remember, the y-intercept is c, so your y-intercept is 4. And what that means is that this graph is going to cross the y-axis at the number 4. So we know there's a point right there. Okay, the next thing we want to know is the line of symmetry. And if you remember, that was x equals negative b divided by 2a. So negative b is the opposite of negative 6, which is positive 6, divided by 2 times a. A in this case is 1. So 2 times 1, which is 2. 6 divided by 2 is 3. So therefore, our line of symmetry is x equals 3. What that means is that x equals 3 is just a vertical line. So our line of symmetry is a vertical line that goes through 3. Now, you also know that the vertex always lies on the line of symmetry. The problem is where? Where on this line of symmetry does it lie? So we use that, or to figure that out, we're going to take x and plug it back into the original equation. Okay? And here's the other thing. So I kind of skipped this part, but we know that the x-coordinate of the vertex is 3, right? It's the same thing. It's negative b divided by 2a.
Okay,
the y-coordinate is going to be found by taking 3 and plugging it back in. So we have y equals 3 squared minus 6 times 3 plus 4. 9 squared is, or 3 squared is 9. Negative 6 times 3 is negative 18 plus 4. This is negative 9 plus 4 is negative 5. So our vertex is 3, negative 5. 1, 2, 3, 1, 2, 3, 4, 5. So here's our other point. So I have to make sure that my line of symmetry just goes a little bit further. Okay? So now, technically, we have enough for a curve, our parabola. If this is 1, 2, 3 units away, the line of symmetry, it's going to create a mirror image, which means it's going to be 1, 2, 3 away on this side. And technically, that's enough right there to create our parabola. But what we usually want is a little bit more than just these 2 points to kind of figure out the shape of the graph. And so you can either pick a point between here or a point on the outside. For something like this where it's 3 away, I'm going to go for something on the inside. So I'm going to use 1. Okay? And so if I plug 1 in, I'm going to find another point. And so that would be y equals 1 squared minus 6 times 1 plus 4. 1 squared is 1 minus 6. That's negative 5 plus 4 is negative 1. So we have 1, negative 1 is another point. That's 2 away. So if I create a mirror image, here's another point. And now you have a little bit better graph. And that is how you can graph these without creating a table. I know it feels a little bit more difficult, but it really isn't once you get the hang of it. You'll be able to quickly identify where this line of symmetry is, and it's really actually, it's not as hard as it looks like right away. Okay. All right. I'm going to leave you with that. If you need to, go back and take a look at this again and walk through the steps. But make sure that you get this in your notes. This is stuff that's needed for this section.